Hi everyone and welcome to Autodesk PowerMill. So we are going to start a new module which is module number 7, and it's all about the verification and it is considered as the second last module. After the module number 7, we will have a final assignment for you or the practicals. So in this module, only we have to discuss about the two topics, which are configuration or configuring the post processor, and we should have to learn about generating the machine codes. So in this module, we have to perform some post processors, or we can say that we have to create some machine instructions and how we can configure the machine instructions. So let's get started. So here I have opened the Autodesk PowerMill Ultimate, and what we are going to do is we have to create a part first, then we go for creating some toolpaths on that part, and then we'll discuss about how we can go and create the G-codes, and as well as how we can go and study about creating the post processors and configuration of the post processors. Actually, the name post processor is called the machine instructions file or instructions that are going to be generated by the software, and that software created the instructions which are directly read by the machine. So we have to ensure that all the instructions are going to be created according to the machine which we have in our workshop. So let's do this. So first of all, I'm going to create a part. So let's create a part or import a part. Here we have the examples. So I'll be here to use the die.djk file. Open it. So what we are going to do is we are going to apply some toolpath strategies on the part, and then we are going to discuss about how we can go and generate the cheats. So let's do and apply the block over here. Just go and calculate the block. Click accept. Going to tell you about the length in x-axis, y-axis, and z-axis as well. So click on the accept to accept the values. Now what you have to do is you have to create some toolpath. So I just go and click on the toolpath. Click on the 3D area clearance because I have to remove a lot of material from the block. So I'll be using the model area clearance for area roughing, or what we can say that we are going to use area roughing operation. So click OK. And now what you have to do is the first task is to give the name, so I'll that as model area clearance. Now you have to select the tool. The most important thing, just think about that the model has a standard work plane, or if you want to create a work plane, you can just go and click over here through the block. I'll be select this point as my work plane. You can go and write the work plane name as well, W1 on this corner edge. Accept this. It's going to be activated. Click on the block, activate it. Because you have selected the new work plane, and according to the work plane, the block position has been changed. So you have to recalculate it. Just go to the tools and select the roughing tool. So I'll be using a end mill rough tool. Set the name, which is 10 millimeters, flat end mill. The die is going to be 10 mm, and the length is going to be 100 mm. Go to the model area detail settings. So it's going to ask you about the style. So while we go and set certain styles, either you can use this raster, you can use the offset model. I'll be selecting the offset model. Set the tolerance value 0.05. Thickness is going to be 0.5. Step over is 5. Step down is going to be 3.5. And just go to the objects over here. Just go to the rapid moves. Select the work plane you have. Calculate it. Go to the leading value, lead out, legs. I'll go and select the step down. Make it save. Select the fields. Now 500, 1500, 350. Take the fly. Click on the calculate, and it's going to calculate the toolpath. So this is the toolpath which is being created by the model area clearance. Click on the close button and it's done. So this is the roughing operation toolpath and is being created on the model area clearance on this die block. Through this, it's going to cut all the material. So if you are going to perform this operation, you need some instructions for the machine. And that instructions are going to be created by the software which is called the post processor. So when we talk about the post processor, we should know about the machine as well. So in the market, we have different types of machines available with different brands, but their controllers have standardized. If I talk about the controllers or the brain of the machine, which read the instructions, it's called the controller. And that controller is very much important while creating the program. So when you create this program and you want to create the instructions for this part or this roughing tool, what we need is we need an ANSI file. So how we can go and create the ANSI file for your machine is that if you go, you see that you have the toolpath over here and you want these instruction file. So what you are going to do is just go and right click over here and you will find out create individual ANSI program. So when you click on this option, it's going to create the ANSI program over here. So these are the instructions which are being shown in the ANSI program. So right now I have to make a post-processor file which is going to be used in the machine. So just right click on it and click on the settings. Here you will find out that the program name is model area clearance and the output file is going to be saved on this directory. If you want to save this file in a certain place, just go and select the folder. For example, I'm going to save this file on a desktop with a name of roughing operation because it's a roughing operation. Roughing operation. Wow. So I'll write the operation name, roughing operation 1, and save it. Now it's going to ask you about the machine tool. So there is no machine available here, but we have to select the machine file. This file is very much important for creating the instructions for your machine which is being available in the factory or in your workshop. I just give you an example that if you have an iPhone, the file extension and the file instructions for the iPhone users are different than the users using the Android phones. So as you know that the Android phones use the APK file for instructions. Same as in the machine, we have to select machine file through which we can able to create the instruction. So what you have to do is you have to select your machine controller file over here. So click on the browse and you will find out here the machine instruction files. But if you don't find out the machine instruction files, then you can just browse out the demo files which are being available in the Autodesk manufacturing post-processor utility. So here you will find out the Alexa, Fanuc, Vegdia, Pass, Khan, a lot of file instructions or machine optional files are available. So all these file instructions are for the milling machines which have 3-axis. So you have to ensure that if you are working 3-axis milling machine, then you have to select your controller files from this directory. One thing you should have to notice that these are the controller files. So if you have a machine named from the Samsung, and then if you look at your controller, then the controller has a different name like controller, then what you have to do is you have to select a controller with the name of Fanuc. So let me select the Fanuc controller because it is the most famous controller around in the CNC field. Just go and select the Fanuc and over. Now this file contains all the instructions through which is going to create an NC file. That NC file is going to be read by the machine controller, and that machine is going to work according to the instructions given in the file. So if I go and click on the accept button, now this machine file is going to be loaded, and all the instructions which is being given like the G codes, M codes, tool path strategies, and moving, and the machine kinematics, all these things are available in this machine file. And these files are by default being downloaded when you download the Autodesk file. But if you don't find out your file, you just have to contact with the Autodesk PowerMill, and then you will ask for the machine files and they will provide you machine file. Or if you don't find out the machine file from the Autodesk, then you have to contact through your machine manufacturing company, and that company is going to provide you the machine option file. So all the instructions are being given over here, like the output, work plane, the part name, the program name, it's going to be one, location, all these things are being given over here, like the codecs. And this file name is going to be saved as roughing operation 1.tab, TAP tab. That's going to be the instruction file. You can just go and change that instruction files. So if I go and apply it, and I just click on the white, the program is going to create the instructions for the machine. So you see that all these instructions have been created, and it's going to be saved on the desktop. So let me show you where are these instructions. So you can see on the screen that roofing operation.tab, this is the machine instruction file, and that file is going to be read by the CNC machine. So how I can open this file? If I just click on the notepad, and if I just go and drag this file in the notepad, you will find out that all the instructions are being given over here. You will see that the percentage sign, you will find out the program name and all the instructions being given over here. Like this is the roofing operation, the part name is model area clearance, the creation date, the program by, PowerMill CB, tool list, tool number, program estimation time, it's going to be 12 minutes and 44 seconds. And you will find out all the J codes and M codes are being given over here. So these are the instructions which are being created by the post-processor utility. And that post-processor utility we have available is the Fanuc post-processor utility. So all the way in the down, all these instructions are going to be read by the CNC machine. And at the end, you will find out that the program is going to be end at this block node. So this is what we call the creation of G codes. By clicking on the PowerMill, we have a facility which is called the Create Individual CNC Program. So if you are going to create individual LC program, then it is going to be help you like that. But if you want to create multiple toolpaths and you want to create multiple tools and multiple toolpaths, and you want to create a single file for all these toolpaths, so how you can do this? Let me show you. So let me right click and make it delete, and I'll go ahead and create a new CNC program file. Okay, and write it final program for data. Okay, I'll go and select the machine option file as well, which is being shown over here right now because we have already been used it. Accept, apply, accept. Now, as you see that this is the roughing operation, and what we have to do is I want to create another operation for rest machining. Just go and create a new toolpath, which is also the rest area clearance. And this way I will make rest model area clearance. This will be using the tool which is not going to be 10 millimeter, but I'm going to use a tool with a diameter of 7. Let me 80-6 is going to be length of 80, and it's going to be the rest machining. Yes, and going to be the step down. The thickness is going to be 0. And this way the tolerance is going to be 0.01. Step over is going to be 1.5 and step down is going to be 0.5. The rest operation is going to be the previous operation which I have, model area clearance. The settings is going to be feed and speed to make it RPM of 12,000 RPM. And click on calculate, and it's going to calculate the operation. So it's going to take some time to load or calculate the toolpath. Okay. And you see that it's going to calculate all the operations on that side, but what is going to be happen? See that it's going to cut down the outer side. So what I can do is just go and apply some limits. So let me go and select some limits over here. Just go and write the name P1 for boundary 1. Composite curve. We turn off this thing. Select it 1. Just go and forward. Apply, set, and set this one. Again, calculate it. So this way is going to we calculated the amount rate. That's going to create some more time to calculate it. Okay. And here we go. You see that it's going to calculate from the inside only. So we have the model area for roughing operation, we have a rest material operation, and if you want to create a finishing operation, okay, let's go and create a finishing operation toolpath as well. So just go and click on the finishing, optimize 3D offsets. Okay, we can just go and create an offset finishing. We write as 3D offset finishing. So what we have to do is we have to create a pattern. So just go and create a pattern over here. Just go and select the curve like that. Accept it. If you want to make it inside direction, make the torus value 0.01. Step over value is going to be 0.5. Just in case of select the tool for finishing operation, I'll be go and use the ball nose mill. It's going to be 4 mm BL nose mill. It's going to be 80. And the RPM is going to be 15,000. Click on calculate. Reload path. You can see that smoothly is going to be applied. So we have 3 tool paths over here, and the part is going to be finished after creating all these 3 tool paths. And what we need is, if I want to create the single individual single NC file for all these tool paths, so what I have to do is right click on the tool path, and you'll see that there is an option create individual NC program. We don't need to use this one. We have to use add to NC program. Okay, so the NC program we have already created. Just click on the add to NC program. You will find out that this part is going to be created over here. So all these tool paths you have selected. So all these tool paths have been created over here, and you will find out it's same. But if you want to create them by singly, you can see that the rest material option is being added over this way. If you want to delete that, just go and press the delete button or remove it. You can remove it. But if I just go and select this one and add to NC program, this thing is being added. Now I'll just go and right click add to NC program, and then add to NC program. You can individually add these programs into this one, or you can select all these things and add to this program. So you can find out that all these toolpath instructions are going to be held under the final program for the die. And what I'm going to do is, if I just go and right click on it, go to the settings, and you will find out that we have the number. This is going to be number 1. It's going to be number 2. It's going to be number 3. You can just go and write the number as well. If you want to set the tool numbers, you can set up the tool numbers as well. So this is the tool number 1. This is going to be tool number 2. I'll go and write the tool number 2 over here. And this is going to be the tool number 3. So I'll go and write the tool number 3. So that's the thing. That's easy. You can go and set up the instructions over here. Although all the instructions we have here is the workflow number 1. So you want to set up the flood, coolant, all these settings going to be set it over here. So you need to save this program anyway. So if I just go and save this program on the desktop with final program for die. So this is going to be the name of the file. Save it. And if you just go and right click on or click on this right button, it's going to create and write the program for all these toolpaths you have selected. You'll see that model area clearance, stress model clearance, and all these things. So this program is going to be a very huge program. It's not going to be a very small program. So close this, apply, accept. If I just go and make it down. So this is the final program. And if I just open that program, you will find out that these are the things. So here are the instructions. You can see that the program is number 1 is going to be use the 10 millimeter flat end mill. Diameter is this one. The next is this. And the tool paths, we have total number of tool paths are 3 tool paths. It's going to take 3 hours and 9 minutes, 11 seconds for all these things. So this is the program, how we can just go and create the NC program by NC instructions for the machines. Or we can say that how we can go and generate the code. So it's just like 1, 2, 3 to create all these instructions. There is no such difficulty in that. So you will find out there is a lot of instructions, and all these instructions are for the all 3 tool paths which we have created. You can see that the tool path number or the block number is going to be very huge. Okay. So this is the huge number block. So that's it for the Autodesk PowerMill, and we have discussed about how we can go and create the codes or NC code for the machines individual, and how we can just go and create the NC codes for multiple toolpaths and create a single file. So that's it for the generation of NC codes. Hope you like it. Thank you very much.